Hi there, in this short demo we'll have a look at how Silico can help you to forecast your company's future margin and improve and optimize it further. We've prepared a short demo model, which you'll see on the screen now, which is based on our extensive experience with especially European chemicals companies, and will run you through what a Silico model can do compared to other methods and what insights you can generate with it to improve your margin. The key challenge with margin forecasting and optimization is that it's a very strategic and top-level view of your organization. So you might, for example, have purchasing managers who are responsible for indicating future material prices and buying these materials. You might have managers in your production process who are in charge of, what products are we making out of these materials. These are then shipped to your customers, each customer buying a certain combination or single sort of source of materials. And then what you're really interested in as the top-level manager is, how does my consolidated margin over all these customers and products look? And that requires you to integrate a lot of different sources of information from different people. And Silico can do exactly that, where traditional methods, for example, margin forecast in an Excel spreadsheet, might fail, which is providing a digital experience for your whole margin forecasting process that integrates and automates much of these different data sources and the process of generating future margins and recommendations out of them. Just to give you a very brief overview of how this model works. On the very left, we have materials coming into our company. We have a make or buy decision for the demo company here, where some of the materials are always being bought from suppliers, but for some we have a choice whether to buy them from suppliers or make them ourselves based on commodities. And there are different sensitivities to commodity prices on the market for these decision points. We can then take a couple of our materials and make different types of products on the product view here. And on that view, we're also accounting for example, energy costs or packaging costs that occur per unit of products that we're producing. We then ship these products to our customers, each customer having different volumes assumptions for different products, having different contracts in place, and therefore maybe different pricing points. They may get different discounts, and they may also have different transport costs depending on how far away they are from our company's location. And on the very right, then we have this strategic overview of a consolidated profit and loss, where we're aggregating over what's our total revenue over all customers and products, what's our material costs over all of these, packaging energy costs over all of these, and so forth, to determine two essential margins. One, if we make the materials that we can make ourselves, and two, if we buy all of our materials. Without wanting to go into the maths of the model, the only thing I want to show you about it in further detail is how scalable our Silico models are. So rather than having thousands of, for example, columns or rows in Excel, we can set up very simple models. For example, we've got one variable here that just captures volume assumptions, and this variable can directly pull from data. For example, we can integrate our software with your SAP database or Salesforce database and many more. And then we can have this variable hold any number of values. So in this case, for example, in the demo, it holds values for a couple of customers and product combinations. And that makes our models highly scalable and avoids typical pitfalls that you get with other modeling methodologies. When you work with Silico, we'll make sure that we develop a simulation model for you that is tailored to your business needs and answers you very specific questions. And these questions we normally answer on a dashboard, which are our interactive tool in which you can engage with models by changing inputs on the left here and seeing straight away how they impact outputs on the right here. And for example, this chart visualizes what's our margin going to be, an absolute amount of pounds, if we make materials and if we buy them. And in this case, you see the blue line, which is making materials, is higher than the green line, which is buying the materials, showing that we should make materials until the end of the year, because that would generate additional profit of about roughly 10% in this model. But we can play around with where does this margin actually lie? Like, what's our margin absolute amounts of pounds if we change different inputs? And is this decision always the best, or are there conditions of inputs that would change whether we should make or buy materials? And for that, we can play around with our inputs on the left here. So a change we've seen particularly this year is that energy prices have increased. And we have a time series input here, and we can change, for example, by how much energy prices will increase by the end of the year, assuming they increase linearly here, or we can assume they do a step change like this. And then as you can see, as you move the slider along, you see our outputs adjust to the new input straight away. But generally, while our margin has some sensitivity to energy prices, it doesn't seem quite as significant, can see a small drop if energy prices per unit increase by £3 per unit we produce, but it's not as significant as the next change we're going to see, which is if we play around with the price for carbon fiber, which might be one of the materials that we use in our production processes, and which impact whether we should make or buy decisions. So for example, our model here has a base case assumption of a carbon price until the end of the year, and this variable changes whether it will be higher or lower than that base case assumption. And if we increase our carbon price, and therefore we have to pay more for the materials we buy, then we see our margin drop straight away. But generally still, we're still better off making rather than buying our materials. But if we do this the other way around and we assume, what if our carbon price is lower than we currently expect it to be, then we can see towards the end of the year, those two decisions actually converge. And then we might be indifferent, or if it drops further enough, we might actually be better off to buy materials in the long term rather than making things ourselves. So what we can understand from this dashboard is A, what is our margin going to be given different input conditions, but it also helps us to understand whether we should make or buy materials by, for example, showing that we can get another 10% of margin if we make rather than buy raw materials. But we might want to think about what else can we do to optimize and improve our margin, especially if we have adverse conditions on the input side affecting it. And we set up another dashboard that represents something we've seen with our chemicals customers that we've been working with. And that is different contract structures that we set up as scenarios. In the base case in blue, we just assume that customers pay a fixed amount per unit of product. But really what we've seen in the chemicals industry and working with those companies is that many contracts have a fixed part, and then they have some variable part that provides sensitivity to market prices. And they're a way to pass on costs, on changing costs on the input sides, but also savings to customers and prices. And thereby they help you stabilize your margin depending on what happens externally to you. And we set these different scenarios up in a way that the more sensitivity they have, with the green contract having the highest sensitivity to market prices, the lower the fixed amount. But they are all set up in a way that in our best case assumptions, they are roughly equal until the end of the year, so that customers will actually go for these different contract structures. And we can then assume, okay, what happens if our assumptions about our carbon fiber price change? For example, if they're going to be lower, then we're going to make more money with the blue contract, and we see a slight decrease for the green contract. But generally, these margins on the red and green contract have stayed relatively stable, but we would have paid more money if we just agreed a fixed term. But generally, if we increase the carbon price and then assume it's going to be higher until the end of the year, then again we see the green and red line stay relatively where they are, whereas our blue line, where we just charge a fixed amount, has decreased because we now have to incur the costs of higher materials. And that's sort of the insight here, is like we can use, for example, pricing structures to stabilize our margin and make sure it doesn't fluctuate as much and isn't that much affected by changes in the market. And that's the insight Silico can help you to generate. So what we've seen in this demo is we can help you forecast your margin in different conditions. We can help you make the decisions that are about making or buying materials. We can also make decisions that we've seen before, which are about should you use materials to make downstream products or sell intermediary materials into the market. And we've seen on this dashboard what you can do to stabilize and improve your margin using different pricing structures.